Okie doke. So I live in North Carolina in the US. My wife is British, and so I get to go there every year or so. And I have a brother-in-law who lives in Australia, and I get to go there a lot less frequently. Um, and what I'm going to talk about a little bit is number one, just a disclaimer about my talents and lack thereof. A little bit about what I've done in LCC, what I'm been trying to do with this particular project, how I did it, and some learnings from my experience. My disclaimer is I'm a mechanical engineer, not an electrical engineer or a programmer. So, uh, I did have do my time in the industry, so I've learned a few things, and I try to muddle through. And as Ringo Starr said, with a little help from my friends. Um, so years ago, I've done a lot with LocoNet, using some Alex Shepard's work with the DIY stuff for LocoNet. I've done a number of nano projects. Uh, I did a thing to do my turntable and roundhouse controls for that. But I started down the LCC path because I really like the things that LCC brought to the table, primarily the ease with which you can configure your nodes and customize the operation of things after they've already been installed on the layout. So I've done some things there. I wrote an article or two in the NMRA magazine. Um, I looked at ESP32s, but that made my head hurt a little bit with the development environment that was really required for those. I like staying with the Arduino IDE. So, I've but I've got tortoises, block occupancy, and signaling all running on my layout using RR Circuits products. Which is they're really nice, they're turnkey, and they work. So real happy with that, but I want to do my own thing. So uh, I started, you know, looking at what it would take, and I settled on the Raspberry Pi Pico. I really like that microcontroller. It's very easy to use in the Arduino environment, um, and so I've started down that path. And my goal is to replace my LocoNet node with an LCC node for my turntable and roundhouse. So this is my layout. It's in the attic. It's a little cramped with the hip roofs, but I've wedged in a fair amount. It's HO, um, and I've got a ways to go on the scenery, but it keeps me busy, which is kind of the goal. I do op sessions. So once a month, I have about 6 friends that come by and we run it. Um, so this is a screenshot of the current controller I have for my roundhouse and turntable, and it's LocoNet, and so that's kind of my focus is trying to do that in LCC, and I really like the event handling in LCC, and it's going to allow me to take this LocoNet node and distribute it across 2 different nodes, one for the turntable and one for the roundhouse, and that should make it operate uh, a lot better. And so, as I said, resources are a great thing. Mike Dunstan, who has been working on the MRC stuff as well as some DIY stuff in LCC, and David Harris, who I believe is on the call, have provided advice and guidance in my journey on hardware and software. And uh, you know, the community that's online is really great for asking questions and just lurking there and reading what questions people have is very helpful. And just look for online for examples, and it's not too hard to figure out. So the hardware that I developed, I spent a lot of time reading data sheets and trying to uh, fit together reference designs and schematics, so I came up with a node um, that communicates with LCC. So the Pico does not have the hardware to connect the transceivers and whatnot to connect. So you have to put that down, uh, and you want to have dual power for your node if you want to really drive some of the things that depend on 5 volts. So I have a dual power chip in there to regulate that. And the Pico also does not have real non-volatile memory. It doesn't have EEPROM put down or FRAM. Uh, so I put that down because if you want to continue to write all of that stuff using the emulation, you're going to eventually wear out your node and have to replace that, which is not a good thing. So my first board was really, this is pretty much the design of my Loconet board with just the communication bits replaced. So I have some very specific connectors on here to go off and talk to the different parts, the stepper motor for the turntable, and I have a display that is a capacitive touch display. And so this was the first iteration. You can see the different things that it controls. Then I came up with just a board for more playing around, and as I decided I wanted to divide that first board up into 2 separate boards, this one just has a simplified set of connectors on it, and I reoriented the Pico a little bit to make it easier to plug in, and the USB connection for programming, and provided some specific pin configurations for plugging in servos and things like that. And then the third board is just a turn on that one where I added back some connectors, and I put in some more specific connectors to drive a NeoPixel bus, and because I also want to deploy this in the rest of my layout to drive lighting in all of my buildings and things like that. So once you come up with the hard bit of a schematic that works, and it's pretty easy to turn a board for a specific purpose. The next bit is the software library. So I'm using the OpenLCB single thread library that David Harris maintains. And it supports a number of different processors. They happily support the Raspberry Pi Pico, and so this has been working well for me. The one thing that David is working on right now is how to make it support external non-volatile memory. So we have been working on that, and I'm sure in the next few weeks the library will get a nice update that can support that. But as is, it works well with using the emulation of the EEPROM that's built into the underlying Pico core sort of software that Earl Philhauer puts out. You'll pick up other different libraries for doing things like NeoPixels and servos and stepper motors and displays and whatever it is you want to connect to it. But those are pretty specific to what you want to do. So the first node that I did, I decided to just pare it down instead of trying to port my very complex turntable node. I decided that what I really wanted to do was just get a node that works well for a single function. So what I did was I focused on the NeoPixel lights. So on my layout, I used these little driver boards that you can get from China for you get 100 of them for $10 delivered to your door in the U.S. So probably not much different in the U.K. And so they're very cheap, and each one will drive 3 separate LEDs or a multicolor LED, and you just put them in a kind of a daisy chain bus, and you can drive all your lights and configure them specifically to how you want them to view on your layout. So what I did was you start small, you pick that task, you do the typical things of setting up your variables and everything, but to the right you'll see kind of a screenshot of part of the CDI, the configuration description part of LCC. So in this, you can tell it how many strings you want. So this supports up to 4 strings. You can control the overall brightness by setting a max luminosity and a dimmed luminosity. So I have an event that says dim all lights, and you can control it that way. I have some effects that I put in here that are dependent upon a frequency that you might put in, like for flashing. And so you can control what that overall frequency is. And then some master controls. So one of the things I want to do is set this up so that using a fast clock in JMRI, if I'm cycling through an operating session over time, I may want different lighting effects to turn on and off at different points in time. So as it turns to evening, I might want exterior lights to come on, street lights to come on. I want business lights to go off and some residential lights to come on, different things like that. So rather than having an event for each light, I do a kind of a group of event. So one would be turn residential on and turn businesses off. And so if those events are tied to the clock, then I can write a script in JMRI that drives all of these lights for me. Going a little bit further through, you can go down to the individual strings, and you can turn the strings on and off. Within each string, you've got individual heads that you can control, and each one of these heads has a red lead, a green lead, and a blue lead. So those are the the three contacts that are on each of those little 10-cent heads that I showed you earlier. And so you can, for each one of those, you can define, how it cycles on and off, uh, whether it's a constant lighting, whether it's blinking, whether it flickers, those sorts of things. You can define what group it's in. You can define its individual brightness level. So once you install all this on your layout, the power of LCC is you can sit at the comfort of your computer screen and define the brightnesses of all of the lights as you're looking at them on your layout, and you can individually tailor and make sure that you've got all the brightnesses of your auxiliary lights in a way that pleases you, without having to take a building off and mess around with resistors, or having to pull a node and work on your workbench. You can install it all, make sure it works, and then tailor it to however it suits you. And that's what I love about LCC. So, uh, my experience is, the first thing, get a piece of hardware that works, and then it's just a simple matter of programming after that. So get an example, learn how to do the CDI, play around with that. Once you have that down, then you can work on how the node actually functions. But set something up on your bench. It's a lot easier to work on the bench than crawling under your layout, and start playing with it, because it's really a lot of fun. As I said, what I want to do is my goal is to replace my turntable and roundhouse. I want to go through my layout and migrate all of my lights to this kind of control. I want to play around with grade crossings. It's a little less common in the UK, but in the States we have a lot of grade crossings and crossbucks and lights and sounds and things like that. So I want to get into those, and I am always watching the Sprague website to see what Andrew's going to come out with, because I'm very interested in migrating to LCC command station and boosters. So I have great hopes for his coming booster, and I'm hoping that might solve some of my reversing loop challenges that I have on my layout. So just understand where you want to go, because otherwise any road will get you there. And I'm a great believer in LCC, and if you want to up your game on your layout, look into it, because it holds a lot of promise. And then just at the end, I've got a couple of things. I'm sure this could get posted, and useful links. Join the groups, read the books, do your homework. There's a lot to learn, but there's a lot of power in all of that learning. And that's all, folks.